Welcome to the channel. So in this third video, we are going to discuss about oxygen hydrogen welding and gas cutting process. Already we discussed about oxyacetylene welding process in the previous video. So if you have not gone through it, I request you to go through it once so that this oxy hydrogen welding becomes very easy. Okay, because it's almost same, only that the one major difference is that the fuel is now oxygen and hydrogen instead of acetylene. Hydrogen is used here. And this method, oxygen hydrogen welding, is an older method compared to oxyacetylene welding, and this is used nowadays for thin sheets of alloy steels and alloys of low melting temperature compared to oxyacetylene welding. And here the temperature, as you can see in the first point, the temperature is around the maximum temperature attained is around 2870 degrees centigrade, which is less than that of oxyacetylene welding. Okay, so the amount of heat generated is less compared to oxyacetylene, and that's why this can be used only for thin sheets. And also the process is slower compared to oxyacetylene. In this case also, first the hydrogen will be released. That hydrogen will take oxygen from the atmosphere, start to generate heat, then only oxygen will be released slowly to get the required amount of heat. So everything else is same, just the fuel is different and heat generated will be less, and then also the process is a bit slower. Okay, so that's why obviously oxyacetylene is more popular compared to oxy hydrogen welding method. Now let's move on to gas cutting process. So gas cutting, what happens in welding, metals are joined together, while in case of gas cutting we are going to separate the metals, and in the first method we will be using gas, that is oxygen and acetylene only, to cut the metal. Now see this figure, you can see the processional view of a burner torch over here, and as you can see, this first figure is for welding. In the first figure is for welding, and from this middle hole there will be oxygen and acetylene mixture coming out, okay, to create the flame for welding process. Now the difference in gas cutting is that instead of one hole, there will be one bigger hole at the center. There will be some surrounding smaller holes. These surrounding holes will be for preheating, okay, and from the center hole there will be oxygen jet, high speed oxygen jet, which will fulfill the purpose of cutting the metal. These surrounding holes will be carrying acetylene along with oxygen, and these holes will be the flames from these holes will be used for preheating the metal. Okay, there is a certain temperature, the range is 800 to 1000 degrees centigrade, and there is a particular temperature called kindling temperature. Okay, that is around 870 degrees centigrade, that we are going to discuss in the next slide. Okay, so until that point is reached, the metal is preheated, and then after the oxygen jet is released at a very high speed to cut the already preheated metal. And the cutting is on the basis of oxidation of metals. As we know that suppose for iron oxidizes very easily to iron oxide. So in that with that principle, oxygen jet oxidizes the metal and the cutting occurs. Okay, so that means if the metal is readily oxidized, okay, if the metal is readily oxidized, then this kind of process can be easily used in case of metals which are readily oxidized. But if the metal is not readily oxidized, suppose aluminum, bronze, stainless steel, etc., so in that case what happens, this process is not very efficient. Okay, so for that we'll have to use some other method or some modifications that we have to do. We will see that later on, what kind of modifications that can be done to get efficient cutting in case of stainless steel, aluminum, bronze, etc. also. Okay, also one another point is that after cutting, the oxides will have to be in the molten form. Okay, because if it is not in the molten form, then again it will solidify, again it will block the cut. It will be like welding then. Okay, so it's not like should not be like that, and that's for that the oxide should have a lower melting temperature than the metal to be cut. Then only the metal oxides will remain in the molten state, so we can separate the metals easily. Okay, as you can see in the third point over here, the oxides must have a lower melting point temperature compared to the metal to be cut. Alright. So that one problem actually happens with cast iron, that we will see what happens with cast iron. In case of cast iron, that oxides having higher melting point than the metal, that is cast iron. Okay, so that means before the oxides or before oxides, the cast iron will melt. Okay, so that should not be the case. And also one problem with steel is that in case of steels with high carbon content, okay, for more than 0.3% content, there is preheating and post heating is needed. Okay, preheating and post heating is needed in case of steels having high carbon content, because if it is not done like that, and if it is left to cool very easily at a high rate, then what will happen? There will be cracks will be formed. Okay, along the cut there will be cracks will be formed, and also it will make the steel a bit brittle. So that's why slow cooling should be done. Okay, the cooling rate should be reduced, and for that there should be some preheating and post heating in case of steel. Then what happens? As you can see, neutral flame is preferred. Neutral flame is preferred to preheat the metal to around 870 degrees centigrade, that I already told you. That is called kindling temperature. Okay, after the kindling temperature is reached only, then only the oxygen is released at a very high speed. As you can see in the first figure, this cut the portion which have already been cut by the oxygen, there will be some lines will be formed like this. These lines are called curve. Okay, and there is a drag, that drag is the difference between the bottom edge and top edge of the curve. This difference is called drag. Okay, this there should be some amount of drag when we use the proper amount of heat, proper amount of speed of the oxygen jet, then there will be some small amount of drag. That is not a problem, that is required, but this drag should not be very large. Okay, the large drag is not desirable, so drag should be as small as possible. Okay, that also we are going to see in the next slide. And as you can see from the bottom side, the molten metal will going out of the metal, molten part will be going out of the metal, and the cut will be uh, cut will separate the metals. But in some cases, if the heat is not sufficient or oxygen jet speed is not sufficient, then proper cut will not be obtained. So as you can see here, this first figure, this is the optimum drag, proper drag, that is for correct pressure and cutting speed. This amount of drag is not a problem. But if excessive pressure and low cutting speed is used, then what will happen? There will be insufficient drag, and due to the insufficient drag, what will happen in the second image, as you can see, this is the top view of the cutting portion cut. In that case, the curve width will be more, okay, which is not also desired, because lots of metal will be lost. Then this curve width will be more, because if we apply excessive pressure. And this is in case of insufficient pressure and high speed. In case of sufficient pressure and high speed, then see lots of drag has been created, which is not also good. Okay, so already this top portion has been cut, and this portion is not yet cut, so this is not desirable. And this is the in case that curve, the width is also very narrow, which is also not good. And as you can see here also, if we correctly preheat it, then what will happen? There will be sharp top edges. Is this edges will be sharp if we correctly preheat it before cutting. Then if we excessive preheating is done, then what will happen? The corners will become rounded. This top edges will be become rounded, which is not also desired. Then obviously insufficient preheating, then loss of cut will be there. Obviously the metal will not be cut completely, so that is also not good. So from this figure you can get an idea of how it should be done. Okay, so as I told you already, cutting cast iron is a bit difficult. About cast iron is that in case of cast iron, the oxides having a higher melting point temperature than compared to the cast iron itself. Okay, so that will not be good, and it will create problem while separating the cast iron from the original piece. And so this is all about the gas cutting process. And see about those cast iron problem and about stainless steel problem, we'll have to apply some modified method in gas cutting, so that this can be done efficiently. So that we will discuss in the next video. So till now, I hope you have understand whatever we have discussed. And at the end of this series, after completing the welding series, we will be discussing some questions that have appeared in GATE exam, UPSC exam, IES exam, so that you will get an idea of what type of questions has been asked previously. So if you have any kind of suggestion or feedback to give, then feel free to do that. Okay, so see you in the next video. Thank you.